So it's one thing to collect data and be aware of how it can be misleading, but it's another and more useful thing to actually organize this data and then represent it in various ways. Let's say that the professor simply jots down all of the results of the midterm exam in his class like this. Although there is some information we can gather from this, it looks quite hodgepodge and it is difficult to get to any conclusions. As such, we need to organize it, and we will do a frequency distribution of this data. A frequency distribution is the organization of raw data like we have here in table form using classes and frequency. Each raw data value is placed into a class. The number of data values contained in each class is the frequency of the class. Here is the frequency distribution of the raw exam result data. It is now a lot easier to make observation on our data, isn't it? Indeed, we can see that the majority of the students scored between 61 and 70%, and that all in all, 8 students did not score higher than 50%. Notice that our frequency distribution has 6 classes. These are 31 to 40%, 41 to 50%, etc., etc. These values are called class limits and help us determine the extent of the classes. Now, to know how large our classes are, we need to find the class width. To find the class width, we have to take the lower limit of a class and subtract from that the value of the lower limit of the previous class. As an example, we can take 41 as the lower limit of our second class, and from that subtract the lower limit of the class previous to that one, which is 31, and it gives us a class width of 10. Now you might be asking yourself, how did I construct this frequency distribution? It all depends on whether we are dealing with qualitative or quantitative data. For qualitative data, we do what is termed a categorical frequency distribution. Let us use example 2.1 from our textbook at page 34. We see here that we have 25 blood types taken from volunteers. Now the first thing to do our frequency distribution is to make a table. We notice that we have 4 rows because we have 4 different blood types. We have 4 columns, one for the classes, one for the tally, one for the frequency, and one for the percentage. Step 2 is to tally the data and place the results in column B. Step 3 is to count the tallies and place the results in column C. Step 4 is to find the percentage of values in each class by using the formula that you see here, where F is the frequency of the class and N is the total number of values in the data sets. For example, in the class of type A blood, the percentage is 5 divided by 25 times 100 equals 20%. Step 5 is to find the totals for columns C and D. The completed table is shown here. For quantitative data, we must instead group into numerical classes. There are a few things to consider before building this type of frequency distributions. Please note that there are many ways to classify data, but for this class we will stick to this one. Rule number 1 is that you should have anywhere between 5 and 20 classes. There's no definite rule for this, but you must have enough classes to present a clear description of your data. Rule number 2, it is preferable that the class width be an odd number. This will ensure that midpoints will have the same number of decimal places than your class limits. We'll come back to midpoints later. Rule number 3, that the classes must be mutually exclusive. This means that there's no possibility that you can place a value in 2 classes at the same time. Rule number 4, the classes must be continuous. Even if there are no values in a class, you must make sure that there are no gaps between your values. Rule number 5, the classes must be exhaustive. You should be able to put all of your data values in your frequency distributions. Rule number 6. The classes must be equal in width. This avoids a distorted view of the data. As such, your first or last class can be opened, such as 54 and above or 35 and less. When you do a frequency distribution for quantitative data, you do a grouped frequency distribution. The first thing to do is to determine the classes. Now, first, you must find the highest value and the lowest value of your data set. In this case, our highest value is 89 and the lowest value is 35. Then, you must find the range of these values. So the range is the highest value minus the lowest value. In our case, 89 minus 35 is equal to 54. You must then select the number of classes that you want. Remember that the only rule for this is that it has to be between 5 and 20 classes. So we have randomly chosen 6 classes. You must divide the range by the number of classes to get the width. Now you notice here that 54 divided by 6 gives us 9, which means that there are no decimal values into our number. Because we have no decimal values, we automatically add 1 to our width. So our width will actually be of 10. If we had had decimal places, for example, if we had had a range of 50 divided by 6, we would have had a resulting number of 8.3. In that case, you always round up to the next value. So in our fictitious example, we would have had a class width of 9. Now the next thing to do is to figure out a starting point for the lowest class limit. This can be the smallest data value or any convenient number that is smaller than the smallest data value. In this case, we have chosen 31 as our starting point. Now, add the class width to find the lower limit for your second class. So 31 plus 10 is equal to 41. Subtract 1 unit to your result to find the upper limit of your first class. So our first class will be 31 to 40. Now that we have our classes, we can do step 2, which is tallying the data in column B. Then, we can count the tallies and put that result into column C, the frequency columns. Step number 4 would be to find the cumulative frequencies. To find cumulative frequencies, you add the frequency in each class to the total of the frequencies of the preceding classes. Here's the example. Now we notice that our first class we have a frequency of 2. So our cumulative frequency, because we have no classes before that, is 2. Now moving on to our second class, what we do is we add the frequencies of the second class to the frequency of the first class. So 2 plus 6 is equal to 8. Moving on to the third class, we add 8 to 11, which is the frequency of our third class, gives us 19. And we do this all the way down until we reach the last class. Now that we have our frequency distributions, we can proceed to learning about how to make graphs.